Welcome to the Tilted Planet podcast, sharing journeys, stories, and a little wonder from around the world. I'm Jack, your host, and today we're turning up the heat as we explore volcanoes, those fiery mountains that build islands, destroy cities, and even shape the atmosphere. We'll look at how they work, the different types, and some of history's most famous eruptions, and even take a brief trip off-world to Mars to meet the largest volcano in the solar system. Volcanoes remind us that the Earth is alive. It's constantly shifting and reshaping itself. So let's peer into the heart of fire. At its core, a volcano is a rupture in Earth's crust, a place where molten rock, ash, and gases escape from deep within the planet. The word itself actually comes from Volcanus, the Roman god of fire. The ancient Romans believed that Vulcan forged weapons beneath Mount Etna in Sicily, one of the world's most active volcanoes. They weren't far off. Etna's fiery activity is indeed the work of colossal forces beneath the ground. But scientifically, what's really happening is this. Earth has layers, as you may already know. The outer crust, the ground we stand on, is just a thin skin compared to the churning mantle beneath. That mantle is partially molten, moving slowly like thick tar. When pressure builds up, it seeks an escape route, and a volcano becomes the planet's pressure valve. When you see a plume of ash rising above a volcanic cone, you're witnessing Earth venting its energy. And sometimes that release is gentle and mesmerizing, like glowing lava oozing across Hawaii. Other times it's catastrophic. Cities buried or burned, skies darkened, global climates shifted. Volcanoes aren't just destructive forces, they're also creative. Much of Earth's land owes its existence to volcanic activity. Entire island chains, fertile soils, and even parts of our atmosphere are directly products of volcanic eruptions. To understand how volcanoes function, we need to zoom out and look at Earth's restless surface. The crust is broken into massive slabs called tectonic plates, which float atop the softer mantle layer below. These plates are constantly moving, very slowly, but relentlessly, colliding or even pulling apart, and sometimes sliding past or under each other. Volcanoes often form where these plates interact and meet. At divergent boundaries, where plates move apart, magma wells up to fill the gap, and this is how Iceland, split by the Mid-Atlantic Ridge, became one of the most volcanically active places on the Earth. At convergent boundaries, one plate sinks beneath another in a process called subduction, melting rock that fuels explosive volcanoes. The infamous Ring of Fire around the Pacific Ocean is lined with these kinds. And then there are hotspots, places where plumes of magma rise from deep within the mantle, independent of plate boundaries. Hawaii is best known for this example. When pressure builds inside a magma chamber, it pushes upward, fracturing rock until it finds its own way out. What follows depends on the magma's chemistry. Runny basaltic magma flows quite easily, creating wide shield volcanoes with gentle eruptions. Thick, sticky magma traps gas until it explodes violently, blasting ash and pumice into the sky. The aftermath of an eruption can shape landscapes for centuries. Lava cools into new rock, while volcanic ash enriches the soil, making regions like Italy's Campania or Indonesia's Java incredibly fertile for agriculture. Volcanoes aren't just a feature of our modern planet, they're a big reason the Earth is the way that it is. In its earliest days, Earth was a molten world, hammered by asteroids and constantly venting heat from within. Volcanoes released massive amounts of gas into the atmosphere: water vapor, carbon dioxide, and nitrogen. That early atmosphere helped trap the heat, preventing Earth from becoming an ice-covered rock. At the same time, volcanic outgassing laid the foundation for oceans and weather systems. So, without volcanoes, Earth would likely have remained too cold and barren for life to take hold. Over billions of years, volcanic activity has acted like Earth's thermostat, releasing carbon dioxide and then locking it away again in rocks through processes like weathering. This cycle has kept Earth's climate within a range that allows life to flourish. And in a way, volcanoes are not just earth shapers, but life givers. Now, not all volcanoes look or behave the same. Geologists generally group them into a few main categories. The first would be shield volcanoes. These are giants with broad, gentle slopes built from runaway lava flows. Mauna Loa in Hawaii is the largest active volcano on Earth, covering half of the Big Island. Shield volcanoes may not explode dramatically, but their size is staggering. Then there's stratovolcanoes, the dramatic conical peaks most people picture when they hear volcano. Stratovolcanoes are layered with hardened lava, ash, and rock fragments. They're responsible for some of history's deadliest eruptions. Mount Fuji in Japan, Mount Vesuvius in Italy, and Mount St. Helens in the US are classic examples. Cinder cones. These are quite a bit smaller. Steep-sided cones made mostly of volcanic ash, cinders, and rock fragments. They form quickly and erode easily. Paricutin in Mexico famously emerged in a farmer's cornfield in 1943 and grew 400 meters tall within the decade. Lava domes, formed when thick, sticky lava piles up near the vent rather than flowing away. These can build quite unstably. They have plug-like structures that sometimes collapse in violent explosions. Then, of course, there's supervolcanoes, which you may have heard of. The rarest, and of course the most terrifying. Supervolcanoes erupt on a scale that can alter climates globally. Yellowstone in the US is by far the most famous, with a caldera so large it can only be recognized from the air. Thankfully, eruptions of this magnitude are extremely rare. We're talking intervals of hundreds of thousands of years. Each type of volcano honestly tells a story of the magma that's beneath it, its composition, its gas content, and the forces that are shaping it. Now, volcanoes have left an incredible mark on human history. Some eruptions were so powerful, they changed the course of civilizations. When Mount Vesuvius erupted, it unleashed a deadly cloud of ash and gas that buried Pompeii and Herculaneum. People's homes and even meals on the tables were preserved under layers of volcanic debris, frozen in time for nearly 2 millennia. It's one of the most famous eruptions ever recorded, and a haunting reminder of nature's raw power. Krakatoa, 1883. Located in Indonesia, Krakatoa exploded with such force that the sound was heard nearly 5,000 kilometers away, one of the loudest noises in recorded history. The eruption created tsunamis, destroyed over 2/3 of the island, and sent ash into the atmosphere that cooled global temperatures for years. Next would be Mount St. Helens in 1980. In Washington state, Mount St. Helens erupted very violently, flattening forests, triggering landslides, and reducing the mountain's height by hundreds of meters. For many in North America, this eruption was a first-hand reminder that volcanoes are not that distant. Ancient phenomena, they're very much alive. This next one in 2010 is hard to say, and I apologize for the pronunciation in advance. Eyjafjallajökull. This Icelandic eruption spewed a massive ash cloud into the atmosphere, grounding flights across Europe for weeks. Some of you might remember this. And yes, that name is quite a mouthful. It might have taken a few tries. While relatively small compared to Krakatoa or Vesuvius, its impact was modern and far-reaching. A single volcano disrupting global air travel in the 21st century. It was something new. These eruptions capture the extremes, from human tragedy to global climate effects, but they also highlight just how interconnected we are with the planet's deep inner workings. Though our focus today is more scientific, it's impossible to ignore the myth and wonder volcanoes have inspired. In Hawaiian tradition, the goddess Pele is said to reside within the volcanoes of the Big Island, her fiery temper shaping the land itself. The ancient Greeks believe Hephaestus, their smith god, hammered away beneath volcanic mountains. In Japanese folklore, Mount Fuji is not only a volcano, but also a sacred site linked to spirits and immortality. These stories reflect awe and fear. For ancient peoples, volcanoes were like living gods, creators and destroyers all at once. Even today, in a scientific age, standing near an active volcano feels like being in the presence of something otherworldly, something powerful. Volcanoes aren't actually unique to Earth. They exist across the solar system, offering a glimpse into the geology of other worlds. The most famous is Olympus Mons on Mars. At nearly 22 kilometers high, almost 3 times the height of Mount Everest, it's the tallest volcano in our solar system. Its base is so wide, it could cover the entire state of Arizona. Olympus Mons is a shield volcano formed by slow, repeated lava flows. But unlike Earth's volcanoes, which are constrained by shifting tectonic plates, Mars' surface is relatively still. That means the same hotspot could feed Olympus Mons for millions of years, allowing it to grow to truly staggering proportions. It's dormant now, perhaps even extinct, but its presence tells us that Mars was once volcanically active. In fact, volcanoes elsewhere in the solar system, like those on Jupiter's moon Io, are still erupting today, powered by tidal forces from giant planets. Volcanoes, then, aren't just an Earth story. They're a universal phenomena, markers of planetary heat, energy, and change. Volcanoes remind us that Earth is quite alive. They shaped our earliest atmosphere, they warmed a young planet, and laid the groundwork for life today. And today they continue to create and destroy, sometimes in spectacular fashion. From the quiet slopes of Hawaiian lava flows to the explosive fury of Krakatoa, from mythological gods to Martian giants, volcanoes connect us to both our beginnings and our future. Next week, we'll venture somewhere in Canada that's completely unexpected, a landscape that's strange, to say the least, shifting, and far from what most people imagine when they think Canada. Thanks for joining me on the Tilted Planet podcast today. Until next time, keep exploring, keep wondering, and tilt your perspective. And if you like this episode, drop a like, a comment, or you can even buy me a coffee with the link in the description.